Okay, so we talk about a function being differentiable if the derivative exists, and we say it exists because the derivative has a limit in the definition, right? So that's why we would use the word exist, because the derivative has a limit in the definition. So it's differentiable if the limit exists. All right, so derivatives are limits. So the limit has to be exist from the right and the left. To be differentiable, it has to be continuous, for sure. Has to be a graph there we have without lifting our pen. And, right, continuous and does not have these four bad things, and you just need to have them memorized. A cusp, right? Remember the cusp is that x to the 2/3 graph. A corner, like the absolute value of x graph. A vertical tangent. So a vertical tangent is when the graph goes straight up and down. So if I was to draw a tangent line right there, that slope would be undefined. So that's when there's no tangent, no derivative, and an endpoint. So if I was to draw a graph like root x, I can't draw a tangent line right there at that point, because there's lots of different ways I can draw a line, a tangent line that crosses at one point. So endpoints, not good. So all of these, there's more than one tangent line that I could draw, or it gives me a tangent line that has an undefined slope. So know these examples, know in words these times when the derivative does not exist. Okay, so is this true or false? If it's differentiable, then it's continuous. If it's differentiable, if I can find the slope of the tangent line, then it must be continuous. Yes, that is true. If it's continuous, then it's differentiable. If it's continuous, then I can find the slope of the tangent line. Nope. Absolute value of x, that's continuous. I cannot find the one slope of the one tangent line there at x equals 0. So this one is false. Okay, different notations, and we'll be going through lots of these reasons and where this notation came from. F prime or y prime, dy over dx, or d over dx of y. So d over dx means I'm going to take the derivative of y. D over dx is going to take the derivative of f of x. Capital D sub x means take the derivative of f of x, or y. Second derivative, so double primes, or d squared, dx squared. Dx is like a thing that we just know that they're both squared. Dx over d squared at y over dx squared, that means second derivative. 2x's, or the squared. So all of those mean second derivative. Okay, this is the position, right? F of x or s of t is the position. One derivative is velocity. Two derivatives are acceleration. We'll get into lots of application problems with that. All right, so let's look at this. This, what can I possibly do? It says explain in words why this is not differentiable at x equal 2. We know what that graph looks like, right? Looks like this. It is not differentiable at x equal 2, just at x equal 2, because there is a corner. So there's a corner right there at x equal 2, so it is not differentiable. But they're still going to ask me to draw the derivative. Okay. So I'm going to draw the derivative. So the only place, so if I'm drawing f prime of x, I cannot use x equal 2 because it's not differentiable at x equal 2, right? So I'm just going to point 2 out here. Okay, so let's look at slopes of tangent lines. So slopes of tangent lines before 2, those look like, well, kind of like -1, right? So always -1, -1, -1 slope, except I can't use 2. Then if I was to draw tangent lines here, they look like slopes of 1. Slopes of 1, after 2, slopes of 1. Oh my goodness, what does this look like? No, it's that graph. Yes. That graph is the picture of the slopes of on the graph f of x equal absolute value x minus 2. All right, so here it is. Ooh, that graph with the little switch up there at 2. Okay, explain in words why this is not differentiable. Okay, so let's graph this thing, which we know looks like this, right? So why is this not differentiable at x equals 2? Well, at x equal 2, it is not continuous. So not differentiable. I can't possibly find the slope of the tangent line at a graph that's not continuous. Oh, graph the derivative. Okay, so here's the f prime. So this is going to be a picture of the slopes. So slopes of these lines, what do those lines look like? They look like they have a slope of 0. So before 2, the slopes are 0. At x equal 2, I can't find the slope of the tangent line. Slopes are 0 again after 2. Well, that's pretty uninteresting graph there, isn't it?